I'll use a die as an example. There. So that's one way in which you can list a set of elements. You could use words or a sentence. For example, A is equal to all the integers from 1 to 6. I could say that. I could write that out in words. So that's another way in which we can do it. I'm not going to put that in here. I'm not going to write it out. But so you have words. And it says that in there. A is equal to all integers greater than 5 and less than 10. Well, A is equal to all the integers greater than 1 and less than 6. So that's a second way in which we do it. You can use set notation. So this is very similar to our domain and range. All right. So set notation would look something like this. A equals x such that 1 is less than or equal to x is less than or equal to 6, where x is an element of the integers. So something like that. That we call set notation. Okay. So what does how does that match with that? Well, 1 to 6 and all the integers in between, 2, 3, 4, and 5. So that would be a set notation. Now you're used to doing that, like I said, when we did domain and range. We use set notation and interval notation. Okay. Now, you can show how sets and their subsets are related using Venn diagrams. Venn diagrams do not usually show the relative sizes of the sets. Sets are equal if they contain exactly the same elements, even if the elements are listed in different orders. You can indicate the number of elements in set A using the notation N of A. All right, so a Venn diagram works something like this. I'm going to use the die, and I'm going to say odd and even. Okay? So the odd numbers, 1, 3, and 5. The even numbers, 2, 4, and 6. So something along the lines like that. So this is a Venn diagram that shows it. In the middle would be anything that is joint between them. All right? This is two sets that we call, and this is a new word, so make a note of it. These are two disjoint sets. Disjoint means that they don't have anything in common in that middle part. Okay. The number, if you see this notation, the N of A is equal to 6. That means that the number of values in A, so this whole thing would be A. We call that the universe, by the way. If it's in this inside the square, that's called the universe. If the number is not in the circles and is outside somewhere over here like that, that means it's not a part of the sets, but it's a part of the universe. So I might be talking about all the numbers from 1 to 7, let's say. Okay? But on a die, we only use 1 to 6. Right? So these are all just kind of get yourself familiar with. Everything that's in A, add everything that is not in A. Okay, so there's the other thing. That little hash at the top there in the right corner indicates that it's not in A, represents everything in the universe. So that is everything in A plus everything not in A should be everything in the universe, which is all together. Okay. So we start from scratch here and make this make sense. All right. Indicate the multiples of 4 and 8 from 1 to 400 inclusive, using set notation and noting any subsets. Also represent the sets and subsets in a Venn diagram. Okay. So the universal set is all of the numbers between 1 and 400. That is all of the numbers between 1 and 400. That's what that shows. I could write it like this, x such that 1 is less than or equal to x is less than or equal to 400, where x is an element of all integers. I could also use something else. What else could I write that as? Actually, there's two other ways I could have written this. It could be integers. It could be what they use, which is n. What does n stand for? Remember a number system from grade 10? Integers, real numbers, whole numbers, and natural numbers. So, you know what? Let me just come out of this for 1 second. I'll come back to it. Let's look at a Venn diagram, all right? The smallest number system that we work with is the natural numbers. So I could write it like that. Okay, so that's natural numbers. The next one that's just slightly larger is whole numbers. What's the difference between natural numbers and whole numbers? Not yet, no. Only one value. What is it? 0. Okay. Then I have that there, which indicates integers, which includes what now? Negatives. Now, are all integers natural numbers? Are all integers natural numbers? No. Are all natural numbers integers? Yes. When you work from the middle out, that means then that this natural numbers is a part of the whole numbers, is a part of the integers. But it does not mean that the integers or whole numbers are natural numbers. Okay? So if you look at the number system, all right, natural numbers natural numbers is that. Whole numbers is this. And integers is that. And what are they all? Real. They're all real numbers. Okay? And what do real numbers include that the other ones don't? Decimals, that's right. Okay? Perfect. All right, now, coming back to this. So when I describe this, I could describe that as natural numbers because I'm starting at 1 and I'm working to 400 and I'm only using all of the whole numbers. So that's natural numbers for that one. Okay. F is going to represent all of my multiples of 4 from 1 to 100. 4, 8, 12, 16, all the way up to 400, right? Okay. Does everybody understand just that right there? Because I'm about to complicate it a bit. Are we okay with that? All right. So X is the universe. So to describe multiples of 4,
That was on my desk, sorry.
I do this. Every number that is multiplied by 4 ends up being a multiple of 4. Agreed? Okay. So X is the universe. So as I go through all of those numbers, remember, I'm only going from 1 to 400. So X has to be between 1 and 100 only. So this is what I mean by complicated. Okay? To describe to somebody all the multiples of 4, I take every value in the universe and times it by 4. But I can only go up to 400. So here's all my X values. So if I go past 100, my 4 times my 101, let's say, is going to give me 404. Well, that doesn't fit into my universal part of this. Okay? So knowing that, let's do 8 now. We're going to skip this part of it, and I want you to do this. E equals what? How do I show a multiple of 8? 8x. That's right. And how high can I go with x where I'm not going over 400? 50. Megan.
When you're describing it within the brackets, do you always use the lowercase?
In this case, they did. I don't know if it's not always. No, it's not always. You use whatever you want. I'll understand what you're doing. They don't want them matching up in terms of both capitals there. Okay? Because the big letter shows what the set is, and then the little letter shows how to get the set. All right? Okay, now, are all the multiples of 4 a multiple of 8? No? Are all the multiples of 8 a multiple of 4?
Yeah.
Yes. So in a Venn diagram then, my universe is 1 to 400. Okay? My universe is 1 to 400. That's all the multiples of 8 are a multiple of 4. We agreed with that? All the multiples of 8 are a multiple of 4. So the multiples of 8 are 8, 16, 24, 32, 40, 48, 54. Okay? All the way up, sorry, 56. 56. So it goes all the way up. All of those are multiples of 4 as well. All right? Okay. Now, one last thing I want to show you. To show that something is a subset of something, you use kind of a reverse, or like I don't know, C. Looks like that. So E, so that 8s are a subset of the 4s, meaning all of the 8s are in the 4s. And all of the multiples of 4s are in the universe. So therefore, it's a subset of the universe. So a subset means that part of your set is included in the bigger set. That's what that means. Okay? So looking at the original question I started with, I have a die that has 6 numbers on it, right? Okay. I could say the even numbers from 1 to 6 are a subset of this. So if I made this my universe, and I listed out my even numbers, and I listed out my odd numbers, I'm going to do you one better. I'm going to list out my prime numbers. Okay. So each of those 3, E, O, and P, are all subsets of the universe. E is a subset of the universe. O is a subset of the universe. And P is a subset of the universe. Now, are any of these a subset of each other? That's correct. They are not a subset of each other because all of the set has to be in that bigger set. So there's no complete overlap when you do this. Okay? Seems complicated, but it's just new. It's new. It's not complicated, it's just new. All right? Now, if I were to draw a Venn diagram using odd and prime numbers, I go like this. I draw my 2 sets, odd and prime. Now, I am going to put the number that is shared by both in the middle. I always start in the middle of a Venn diagram. What number is shared by both of those? Well, actually, we have 2, don't we? 3 and 5. Okay? What's the one value that's an odd value but not a prime number? 1. What's the one value that's a prime number but not odd? 2. Let's call this my universe. How many values are in my universe? How many? 4. I don't have to count 3 and 5 twice. So the number in the universe is 4. That basically sums up all of today. Okay. I want to introduce to you page 66. I'll do this very briefly, and then I'll give you more explanation tomorrow. Sets that are not disjoint, which means they share common elements. When drawing or looking at a Venn diagram, keep the following in mind. Each region of the diagram represents something different. Each element in a universal set appears only once. An element that occurs more than one set goes in the region where the set contains the element overlap. To count the elements in non-disjoint sets, count the elements in each region just once. Okay, so there's a little bit of a trick to this, but it's still very, very simple. And a Venn diagram is a fairly simple tool that will help you solve these questions. Chantal asked 36 people at a senior citizen's residence what types of movie they liked with the results shown. She wants to use the data to answer these questions. How many people like both, or like mystery or comedy or both? How many people like mystery only or comedy only? And draw a Venn diagram to show the data. Okay, so here's my universe. Mystery movies, comedy, and neither goes on the outside. So the first thing that I can do is do the neither part. I'm gonna put that up there. Because we know that that's 6. All right, it is not in the mystery, it's not in the comedy, it's on the outside of it. So far, so good. All right, count that up for me, would you? I have 20, 15, and 6, which makes 41. However, I only asked 36 people. So what happened there? People could have liked both. So the first thing that you do, here's the first thing. You take the number of people and you subtract the neithers. Okay? So I had 36 people asked and I minus 6, which gives me 30. Yes? Okay? Now, between the two, I have 35 people who like mystery or comedy. So 30 people like one or the other. 35 people like one or the other. But I only had 30 people liking a part of this. So now what I want to do is I'm going to find the middle part of this. To do that, I take my total, which is 35, 20 like comedy, 20 like mystery, 15 like comedy, that's 35, yes? And then I'm going to subtract the 30. That's going to give me how many people like both. That 5 goes in the middle here. So take the neither out of there, take the overlap and subtract from the number that you know liked one or the other, and that gives you them both. It's the same every question. Okay? So if a total of 20 people like mystery, but 5 people like both mystery and comedy, how many like just mystery? 10. And how many like just comedy? Oh, this isn't right. That is actually 15, and this is 10. If 5 like both, that means that only 15 like mystery and 10 like comedy, and not the other. Simple diagram. Only 2 questions to do on 3.2. Done the exact same way. Okay? All right. Start on page 60 and work through that.